Today's lesson will be with 9.2 on reflections, actually 9.3 based on reflection from your text. When you have a reflection, you're just going to be flipping an object over or creating its mirror image. Okay, you always want to make sure that you check to see that that's how the construction looks when you're finished. Okay, look to see, did it flip? Okay, does it look like its mirror image? We're going to look at some coordinate rules algebraically and how to analyze these and graph them just a little bit so you can see how they work. All right, so on our note sheet, okay, that you're going to see, okay, we are going to work with determining and applying the rules of a reflection in our coordinate plane. So a reflection is going to be one of our transformations that creates a mirror image of your object. Okay, this transformation is considered to be a rigid motion. Okay, anytime one of your transformations is a rigid motion, it's going to create another congruent figure where one would fit exactly over the other. Okay, that one's real important in a reflection that you can see that because that's a little bit how we construct it. So just if we were investigating this, if I wanted to reflect this not equal sign right here over this line of reflection, okay, what I could do is I could take my paper and I could fold it along that line of reflection, okay, and trace that not equal to sign on my paper so I could see where that would be located when I flip that over. Okay, when I open up my page again here, we should notice that the not equal to sign, and I trace back over the top so you could see that a little bit better, would be located right here. Okay, this is considered a rigid motion because this not equal to sign just flips or creates its mirror image right over here, but one would lie directly over the other. Okay, you're gonna notice that it just doesn't go straight across because my line of reflection here is at a slant, okay, or a slope. So it's gonna angle that downward as it flips that over. If you were ever to take a corresponding vertice, okay, like these two right here that are flipping over this line of reflection, you should be able to connect those corresponding vertices and they should cross your line of reflection at 90 degrees, and whatever distance it was away from the line of reflection, we want that same distance to occur over here. Okay, so those are just some properties with reflections that you do want to keep in mind. Now, when we look at common reflections, which we're going to do here, we're going to look at rules that will work algebraically for certain scenarios. Oftentimes on a graph, we will reflect or flip over one of the axes, either the x-axis or the y-axis. So here is what will be, okay, my algebraic rule, okay, for flipping over the x-axis. But I want you to kind of investigate that. Okay, look at how this would occur with a point. So if we were to look at my graph right here, and I was going to start with the point, and we're just going to use this one for each of our investigations. Okay, -2, 6. I would start by graphing the point -2, 6. I should recognize if I was going to flip that over the x-axis, okay, it would just flip from the second quadrant right here down to the third. And I could just count those units. I'm 1, 2, 3, 4, 5, 6 units away from the x-axis. So I'm going to move 1, 2, 3, 4, 5, 6 units below. Okay, so it would flip. If I were to take it and fold it over that line, it would just flip over the x-axis. So this would end up at -2, -6. And you can see if I were to connect that then, okay, those do connect at a right angle and those distances stay the same. But hopefully you kind of recognize the relationship between these points. Okay, the x coordinate stayed exactly the same. It was -2 and it's going to be -2. Okay, this is my pre-image to my image. And then the pre-image point coordinate of y was 6. It goes now to -6. So you should see that the y coordinate just changes sign. It was a +6, it now goes to a -6. So in our rule, we show that y just takes the opposite sign. So that rule is any pre-image xy is going to reflect to x negative y if we're reflecting on the x-axis. Now, if we were to take a point on the y-axis, and we'll take the same point, so -2, -6 would be located right here. And I'm going to flip it over the y-axis. So it's 2 units away from the y-axis now. I'm just going to move 2 units over. So then I would notice that its coordinates would then be at 2, 6. So if I look at a rule here, okay, the x-coordinate is going to change to the opposite sign because -2 goes to +2. And the y-coordinate 6 stayed at 6. So when I write that out as an algebraic rule, the pre-image xy will move to the image -xy if you're reflecting over the y-axis. And then our next most common type of reflection is reflecting over our diagonal line. So we've put in a line that cuts the graph exactly diagonally. And I kind of call this the positive diagonal because this line has a positive slope. If we were to put that in slope-intercept form, that diagonal is going to have the equation y equals x. So if we reflect on y equals x, okay, here's my point A again, which is at -2, 6. Okay, what I noticed is that it's moving diagonally now, so not a specific number of units that I can count out. So I'm going to need to make that distance horizontal and vertical distance. So I would notice to get to my line of reflection here, I had to move down 1, 2, 3, 4, and then to the right 1, 2, 3, 4. Okay, the reflection has to do the same thing. So down 4 and right 4. Okay, if I do that, then you can see when I connect those, it would make a perpendicular with the line of reflection. And I move the same number of units. So those distances are going to be the same. Now I'm just going to look at where A prime ended up. A prime ended up at 6, -2. So looking at those coordinates, you should see that we just switched them. Okay, what was the x-coordinate now becomes the y-coordinate, and what was the y-coordinate now becomes the x-coordinate. So if we write that out as an algebraic rule, the reflection over the line y equals x will become x comma y reflects to y comma x, okay, as your rule. Okay, go ahead and use this knowledge then to actually work with a graph itself on reflections. Okay, so in this case, if I look back here and I look back at what my rule is going to be for reflection over the y-axis, I can use this rule. xy goes to -x, comma y. Okay, or it's going to flip it over that y-axis. So you could see, for instance, if point A is located here, then it's 1 unit away from the y-axis, so we'll move 1 unit on the other side of the y-axis. So that would become A prime. Okay, B right here is 1, 2, 3, 4 units from the y-axis, so it's going to move 1, 2, 3, 4 units over here. So there would be B prime. C is 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8 units would be right here. There's C prime. And then D is 1, 2, 3. So we move 1, 2, 3 in this direction. There would be D prime. And again, you should connect your figure, okay, with your ruler or protractor here. Make sure that everything is nice and neat as best you can here, because once you draw your picture out, this should look like an isometry. And it should look like we took one figure and flipped it over the y-axis to create that reflection. Now, what we want to do is we want to check all our coordinates. Okay, make sure those came out accurately. Okay, so A was originally located at 1, 5. So A prime would then have to follow this rule. It should be where the x coordinate has the opposite sign. So -1, 5. If I take a look, -1, 5 is where A prime ends up being located. Okay, B was located at -4 and 1, 2, 3, 4. So B prime, that should change sign, should be at 4, 4. And 4, 4 is where we see B prime. Okay, C was located at -8, -3. Again, if I were to change the x coordinate, that should place it at 8, -3. So here's 8, -3 for C prime. D was at -3, -2. And again, x coordinate should change sign, so that should take it to 3, -2. And there's E prime in there. So always kind of check those coordinates to make sure your graph is coming out accurately. And again, you try in this next example to see if that works itself out. All right, good luck with your reflections. Please keep in mind that you may need to reference your text in lesson 9.3 for some additional details and how just different examples within this lesson work. All right, good luck.